try another one. Number three. P or not Q. P or not Q. R or S. Q and not R. And then the conclusion is P and S. Let me just check that, make sure I wrote it right. P or not Q, R or S, Q or not R, P and S. Okay. Yeah. Alright. So here's, this is number 3. Again, we're going to try and determine the truth validity of this argument. By all means, feel free to pause the video, solve the problem, come back to check to see if you did it right. Okay. So, what's the first thing that we do? Again, the first thing that we do is I need to find all my statement letters in my argument, right? I want to identify all the statement letters in, and this is argument number 3. So I want to identify all the statement letters in argument number 3. So we have P, we have Q, we have R, we have S. So we have P, Q, R, S. Q we've already assigned, R we've assigned, P and S. So we have P, Q, R, and S. So those are the statement letters that we have in this argument. Again, we're attempting to assess the validity. So step 1 is complete. Step 2, we need to assign truth function to our premises and a false claim to our conclusion, right? So we have 1, 2, 3 premises this time, and our conclusion, right? So we need this to be true, this to be true, this to be true, and this to be false. If we can do that without having to assign inconsistent truth values to a statement letter, then the argument is valid. If we don't need to assign inconsistent truth functions to a statement letter, then it's invalid. Let's see. Alright, P and S. Well, P and S, well, what can we do in order to make this assessment? Well, we know that in order for this conjunct to be true, right, in order for the conjunct to be true, and again, you'll have to go into truth tables in order to sort of brush up on this if you don't know this offhand, but in order for your conjunct to be true, both of your statement letters need to be true, right? You can't have one true and one false. Both need to be true. If both are true, then you know your statement is true. So in this case, we get to knock out at least one of them, right? We get to knock out at least one of them, right? So it helps, but it doesn't help too much, right? So we have P could be, let's say, false, right? If P is false and S is true, then it would be false, right? If P is false and S is true, then it would be false. But if P is true and S is false, then that could be false as well. So we're actually not too clear on this first step, right? We're not too clear on this first step, whether or not P needs to be true or S needs to be true, or the truth, the truth value of our statement letters. So let's come back to this, right? And I gave this example deliberately because I wanted you to see what complications might arise, right? So we can't determine the value of these just yet, right? Because falsity, there's many ways we can arrive at a false claim. It could be false false, it could be true false, it could be false true. Insofar as any of those 3 circumstances arise, we don't know what the appropriate letter should be just as yet. So let's go to something that looks a little bit easier. Well, what might be easier to assess? Well, let's look at line number 3, right? Premise number 3. And you can do any premise, right? But, you know, just let's try premise number 3. We have Q and not R, right? We have Q and not R. Well, let's start there. If we have Q here, and we see that we have Q here, so we have Q in 2 lines, and we have R in 2 lines, right? We can attempt to see if it holds, if the truth value holds on line 3. So let's say we assign true to Q. Right? Let's say we assign true to Q. And I've just arbitrarily assigned true to Q. I can also try arbitrarily to assign truth value to my conclusion. I chose not to, right? Because it's not as clear in this. So let's say I chose arbitrarily to assign true to Q. Well, if Q is true, right? If Q is true, and I need this to be true as well, right? Because this whole claim needs to be true. If I assign true to Q, then I recognize that in order for this to be true, this has to be false. R has to be false. Not false is true. True and true is true. So I recognize that on this assumption, R has to be false. Right? R has to be false. If Q is true, then this is true. And if R is false, then not false is true. So true and not false is true. So this works. Now what we can do is plug in our false for R in line 2, right? We can plug in our false for R in line 2. So we'll do that. If R is false, then we recognize S has to be true in order for the statement to be true, right? If R is false, because we needed it to be false here in order for the claim to be true, if R is false, then we recognize that S has to be true, right? Because if it's false and this is true, then the whole claim is true. So then S must be true. If R is false, either it's false or it's true, it is true. Okay? So S is true. So now what we can do is we can substitute the rest of the variables in. It should be easy. You should be able to see now what the answer is, right? We can go to Q. We already have Q assigned. We said that Q is true. So if this is true, not true is false. We need this to be true, not true. Q is true, not true is false. So P has to be true in order for this to be true. P has to be true in order for this to be true. Now, if I plug true in for P, if I plug true in for P, and I plug true in for S, and I plug true in for S, true and true is not false. So what I recognize is that either, it doesn't really matter which one, I can't assess now, given the level of logic that we're using at this point, I can't assess now which variable the inconsistency arises, but to be thorough, we can do this. We know it's P and S, as we knew early in the beginning. Right? We knew that in the beginning. I knew that in the beginning, you knew that in the beginning. What I did is I worked around to show you, right? We recognize then that this argument has to be valid. Right? This argument has to be valid because the only way that I attain true premises and a false conclusion is by substituting an inconsistent truth value to a statement letter. Right? That's the only way that I arrive at an invalid argument. Either P is true or false, or S is true or false. That's the only way that I can make this work. And just quickly to go through that again, I'm not going to go through it because I just did it, but to sort of very quickly go through it, what I did was start with, and you can start anywhere. I, for whatever reason, decided to start on premise 3. Right? Premise 3, we recognize we assign truth for Q. Assign truth for Q. Well, in order for this to be true, I assigned R for false. Not false is true, so true and true is true. I satisfied that condition. I went to line 2. Once we recognize that R is false, if this is false, then in order for this to be true, S has to be true, right? So I substituted true in for that, and that made that true. Then I recognize that I've already assigned Q, right? I assigned Q in premise 3, so I assigned Q. Q has truth to it. Not true is false, therefore P has to be true, and that satisfies that. But I need my conclusion to be false, and I've already assigned, up until that point, truth to both P and S. So in order for this to be false, the only way that my conclusion can be false is either having an inconsistency in P, in the attribution of truth value to the statement letter P, as true and false had to be inconsistent, or an S as true and false had to be inconsistent. That inconsistency shows that my argument is valid. So number 3, quite a bit more complicated. Hopefully I worked through it slow enough, but you see that 3 is valid. And actually this is a lot easier. If you were going to use a truth table to symbolize and assess the validity of this argument, it would be very, very, very complicated. Not complicated per se, it would just be very time consuming, right? It would be lots of component parts to the assessment. This is relatively easy. Okay.